Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for previous NEET questions from the chapter Magnetism and Matter. Let us start from the first question. The magnetic susceptibility is negative for. So remember, susceptibility in general is represented by letter chi. So since ferromagnetic and paramagnetic materials can react to the external magnetic field, so diamagnetic material does not react to the external magnetic fields. So therefore, diamagnetic material poses susceptibility negative. Moving to the next question. A bar magnet is hung by a thin cotton thread in a uniform horizontal magnetic field and is in equilibrium state. The energy required to rotate it by 60 degrees is W. Now the torque required to keep the magnet in this position is. First, let us write the equation of torque. So torque is equal to mb sin theta. So theta is 60. mb sin 60. Sin 60 you might know, root 3 by 2. This is the torque. Get back the equation of work done when the magnet is rotated due to torque. So mb cos theta 1 minus cos theta 2. Initially it is in equilibrium state. So therefore, theta 1 is equal to 0. Theta 2 is equal to 60. So now W is equal to work done. So mb will be same. Theta 1 cos 0. Cos 0 is 1 minus theta 2 60 1 by 2. If you simplify this, so LCM will be 2. 2 minus 1. So it will be mb by 2. Call this is equation 2. Call this is equation 1. Dividing 1 into 2. Torque by W is equal to mb root 3 by 2 divided by mb by 2. 2 get cancelled, mb get cancelled, so it will be root 3. So therefore torque is equal to root 3 W. The second option is correct. Moving to the next question. Yeah. A 250 turn rectangular coil of length 2.1 centimeters and width 1.25 centimeters carrying a current of 0.85 microamperes and subjected to magnetic field of strength 0.85. Work done for rotating the coil by 180 degrees against the torque. So work done. So already you got the equation W is equal to mb cos theta 1 minus cos theta 2. But B is given in the question directly, but M is given indirectly. So get back the formula. M is equal to number of turns of current carrying through the coil with area of cross section. You'll get this particular equation from the Biot-Savart rule application, magnetic induction at the center of the circular coil, and in association with magnetic dipole moment along the axial line and what is magnetic field. So on comparing those two equations, you'll get this equation. So this particular equation will come in theory. So let us directly go to the new question. N into I into A. So cos theta 1 minus cos theta 2 along with the B. So N is number of turns, it is 250 turns. I is 85 microamperes. Micro means 10 to the power of 6. Area is associated with the length and width. It is 2.1 into 10 to the power of minus 2 because it is in centimeters. Length into breadth, you call it as width as breadth. So it is 1.25 into 10 to the power of minus 2. Even. So there is B. B is also 0.85. Coming to theta 1. So theta 1 initially it is in equilibrium position. So theta 1 will be 0. Theta 2 is 180. So it means cos theta 1, cos 0 is 1 minus cos 180 is minus 1. So therefore it is 2. So if you simplify this, you will get the equation, you will get the answer as 9.1 10 to the power of minus 6 joule. So you can check the calculation. Now moving to the next question. So this is from orthomagnetism. If theta 1 and theta 2 are the apparent angles of dip observed in two vertical planes, which are at these planes are at right angles to each other, then the true angle of the dip theta is given by. So true dip in general, tan theta is equal to vertical component of magnetic field by horizontal component. Yeah, so therefore, when you go with tan theta 1, it will be BV. BH can be written as BH cos theta 1. Thus, theta 1 and theta 2 are the apparent dips. BH cos theta 1 in the first case. The next case, when you write tan theta 2, BV, BH cos of, directly they have given theta 2. Okay. Otherwise, you can write with sin theta because these two planes are at right angles. So planes are at right angles means once you decide one is the angle theta 1, so other angle will be 90 minus theta 1. So 90 minus theta 1 you treat it as theta 2. So first angle is theta 1, second angle is 90 minus theta 1. So therefore cos 90 minus theta 1. It is sin theta 1 BV by BH sin theta 1. So cos 90 minus theta 1 itself is this one, sin theta 2. So therefore, now, so writing sin theta 2, sin theta 1, sorry, this is sin theta 1. Yeah. So it is going to be, otherwise you don't need to write this one, directly write sin theta. Yeah. Is equal to, sin theta is equal to, yeah. So BV by tan theta 2. This is in the second case. In the first case, cos theta is equal to BV by, sorry, I forgot to write BH. So therefore, BH tan theta 1. So squaring and adding. So sin square theta plus cos square theta is equal to BV square by BH square. First case tan theta 2 square, tan square theta 2 plus BV square by BH square. So tan square theta 1. Then yeah. So what is BH by? You take out common BH. BV square by BH square. It will be 1 by tan theta 2, tan square theta 2, tan square theta 1 is equal to, so this is BV by BH is tan theta. So this is anyhow 1. Now 1 by, because BV by BH square, it will be tan square theta. So if you take it down, it will be tan square theta denominator. 1 by tan square theta 2, 1 by tan square theta 1. Therefore, reverse. So reverse will be cot square theta is equal to cot square theta to cot square theta. So this is the answer. So if you have any confusion, so maybe in case if you go with theta, this is theta, you take this is 90 minus theta, so that you'll get sin theta. Yeah. So tan theta 1, tan theta 2 will continue. So last option is correct. Next. A thin diamagnetic rod is placed vertically between the poles of an electromagnet. When the current in the electromagnetic is switched on, so then the diamagnetic rod is pushed up out of the horizontal magnetic field. Hence, the rod gains gravitational potential energy. The work required to do this comes from it is due to current. So the appearance of current makes the diamagnetic rod to go up. Yeah. Moving to the next question. This is also theory. At a point A on the Earth surface, the angle of dip is plus 25. At point B on the Earth surface, the angle of dip is minus 25. Understand? Plus 25 and minus 25. So we can interpret that. So A is located in the, so if it is positive, A is located in the northern hemisphere. So since it is given negative dip, so it is located in the southern hemisphere. Next, moving to question number 7. An iron rod of susceptibility 599 is subjected to a magnetic field 1200 ampere per meter. Permeability of the material is the question. So first you get the relation between susceptibility and relative permeability. Susceptibility and relative permeability is chi is equal to mu r minus 1. So therefore mu r will get chi plus 1. So chi is 599 susceptibility plus 1. This will be 600. So therefore now mu is equal to mu r is equal to mu by mu naught. You got mu r as 600. Mu you are looking for, mu naught is 4 pi into 10 to the power of minus 7. So therefore this is 600 into 4 pi is 12.56. You don't change it. 4 pi you write as is because all options are with pi only. Into 10 to the power of minus 7. So therefore what you can do is 1, 2. So this will be minus 5. So 6 4s are 24. But okay, most of the options are given 2.4. So 24, initially 24 pi into 10 to the power of minus 5 Tesla meter per ampere. So therefore, if you want to get minus 4, this will be 2.4. So answer is 2.4 pi into 10 to the power of minus 4. Yeah. Next. The net flux through any closed surfaces, it is going to be 0 because difference is the question. So let us say this is the surface area along which the magnetic lines of force enters and magnetic lines of force leaves. So therefore, when they enter, you call this a flux is 1. When they leave, so same number of lines of force enter and same number of lines of force leave. So therefore, when these two are equal, so difference will be what? Difference will be pi 2 minus pi 1. So since same number of lines of force enter and leave, so therefore answer is 0. So pi 2 is equal to pi 1. So they get cancelled. Thank you, students, for watching my video. But don't forget to share and subscribe with your friends and relatives. In the next class, I'll continue explanation for previous NEET questions from the chapter EMI. Thank you very much.